Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 10 of lesson number 8, motion. Now this can be one of the lesson where we'll be ending up with the whole lesson, or we might require one more part. Let's see, because there are many activities as well that we need to discuss as right. So before I start with this part 10, I want each one of you, and I hope that each one of you have a you had proper revision of whatever has been discussed. Okay. So I want every one of you to please revise whatever notes that you have taken in your book. Okay. Because that is what is very important for you, right? So we have started the lesson by discussing about motion in detail, right? And along with that, we even discussed on different examples of motion, which includes like rotation and revolution of Earth, continuous expansion of the universe, ball rolling down the hill, train traveling along the track. These are some of the examples of motion. Now apart from this, because you are studying the lesson like motion from till part 9, we have already done it, so you should come up with your own example with like where you can find that there's motion involved in it. Okay, so I want each one of you to please go through it quickly. Like now you don't have to see it on screen, you just have to let yourself know what all things you're aware about motion. Like if I give you to write a note on motion for 2 marks, what all points you're going to come up with. Okay. After this, describing motion in detail along with example, we discussed on motion along a straight line. So I just want each one of you to please go through this, and like the here we have discussed on motion along a straight line along with an example, right? So you should be even knowing this as well properly. So I want you all to please go through it quickly. After this motion along a straight line, we discussed on this activity 8.1, and now you are revising like the observation, explanation, and conclusion for this activity, like since all the parts. And I hope like you all are very much clear with it now. After this activity 8.1, we even discussed on activity 8.2. So I want you all to please go through it quickly as well. After this activity 8.2, we discussed on like uniform and non-uniform motion. So I want you all to please even go through this part, as well as like you can get a question, a direct question on to write a note on uniform and non-uniform motion. Okay. After this, we discussed on non-uniform motion, right? So like you can even get a differentiation between uniform and non-uniform motion. Okay, so make sure you know that as well. After this, we discussed on this activity 8.3. So I just want you all to please go through it quickly. After this, we discussed on like measuring the rate of motion. Now you should be very much clear with every concept, and the time that you take to revise should be reduced as well. Okay? Then here we have the formula for average speed, that is equal to total distance traveled, which we represented as S, and the total time taken, which we represented as T. Okay? Then we discussed on the example like how exactly we can calculate the average speed of the object. So this is the most basic example. You just have to use the formula, and according to the formula write the numbers and then calculate it, right? After this, we discussed on like speed with direction. So I want you all to even go through it as well. Okay, I hope you all have gone through it because here we have the, you can say, formula for average velocity, that is equal to initial velocity plus final velocity divided by 2, right? After that, we discussed on activity 8.4. So here also you have discussed about observation, explanation, and conclusion, right? Then we had activity 8.5 where we discussed about lightning and thunderstorm, right? So I just want every one of you to please go through it quickly. Then after this 8.5, we discussed on example 8.2. So I want you all to please go through it as well quickly. I hope every one of you are going through it. After this example, we had one more example over here, which let us help us in calculating the average speed as well as the average velocity. Okay. After this, we discussed on like rate of change of velocity. Okay, so please go through it quickly because we are like left with only one part after this. We'll be discussing that as well. Then we discussed on acceleration. So here we have the definition and formula for acceleration. I want you all to please go through it quickly. After this, we discussed on this activity 8.6 as well. So I hope every one of you are going through it as well. Then we discussed on this example 8.4 as well. So I hope you all are going through it. After this, we discussed on the graphical representation of motion, and all the three graphical representation we have already seen, like the equations for that, right? So please be quick with it so that we can like revise that and we can start with the further part as well. Then we discussed on the distance time graph, and after that we even had velocity time graph as well, right? So I hope you all are going through it. So this is what we discussed based on the table that was given before, right? On the basis of that, the graph that can be obtained is like this. Like this is the distance time graph for a car moving with a non-uniform speed. Okay. Then after this we had the velocity time graph. Over here also we have like one for uniform motion and the other one for non-uniform motion. After this, we discussed on the velocity on the table that has been given over here, that is with respect to velocity of a car at regular instance of time. Okay. After this, we discussed on because we had to make a graph on it, right? This graph, so we even discussed on how can we make that, and which are the different areas and the distance traveled given, right? Then this is the graph that you will obtain for the velocity part. Okay, and make sure you know it properly how to draw it as well. Okay, then this are with respect to uniform, uniform and non-uniform accelerated motion. Different graphs have been shown, so I just want you all to please go through it quickly. Then we discussed on activity 8.7. So please go through it as well, because you might have interpreted a graph as well for the same, right? Then we had one more activity where you have interpreted the graph on the same as well, right? Then after this, we discussed on the equation of motion by graphical method, and here we have like the three different equations which have been given, right? Then we discussed on the equation for velocity time relation. I want you all to please go through it as well. So you need to go through the like figure 8.8 as well, where they have shown the velocity time graph to obtain the equation of the motion. Now equation of motion, when you calculate it properly, you'll get the equation as v is equal to u plus at, where v is the velocity, u is the distance, and a is acceleration, t is time, right? After this relation for velocity time, like equation for velocity time relation, we have equation for position time relation. So I just hope you all are going through it. I hope you all are going through it. After this, we discussed an equation for position velocity relation. So the equation that will come up at the end is S is equal to v plus u multiplied by v minus u upon 2a. Okay. After this, now, like we even discussed on this example 8.5 and 8.6, right? So I just want you all to have a quick glance through it. Then we even discussed on this example, so please go through this as well. I hope every one of you are going through it. So after this, like we even discussed on this example 8.7. So I just want you all to please go through it as well. Now we have uniform circular motion to discuss. So see, when the velocity of the object changes, we say that the object is accelerating, right? When do we say that the velocity of the object has changed? When the object, like whenever you see that the object is like the velocity of the object is changing, it's because the object is accelerating, right? So the change in the velocity could be due to the change in its magnitude or because of the direction of motion. The reason can be both. So now can you think of an example when an object does not change its magnitude of velocity, but it only changes its motion, like its direction of motion? Can you think of any? So let us consider an example of the motion of body along a closed path, and here if you can see the figure 8.9, the A1 is, it shows the path of an athlete along a rectangular track ABCD. What does it show? It shows the path of the athlete along a rectangular track ABCD. So let us assume that the athlete runs at a uniform speed on a straight path AB, BC, CD and DA of the track. So you have to assume that the athlete is running on that path. Okay. Now in order to track himself, like keep himself on a track, he quickly changes his speed at the corner. So how many times will the athlete have to change his direction of motion while he completes one round? What do you think? How many times the athlete have to change it? And do you think, is it clear that to move in a rectangular track once, he has to change his direction of motion 4 times? Do you think, is it the case? Yes, it is, right? So here we have more information on it. Now suppose instead of a rectangular track, the athlete is running along a hexagonal shaped path, that is A, B, C, D, E and E, F. So if you can see this hexagonal path that has been given, that is like B, right? So in this situation, the athlete will have to change his direction 6 times because it's an hexagon. Hexagon has 6 corners, right? So what if the track was not a hexagon but a regular octagon? Now regular octagon will have 8 sides. That has been shown in figure C. Okay. So in that case, it is observed that the number of sides of the track is going to increase the athlete, and he will have to take more and more turns often. So now tell me, what will happen to the shape of the track as we go on increasing the number of sides indefinitely? What do you think? The track will remain the same, it's just that the athlete is running, right? So if you do this, you will notice that the shape of the track approaches the shape of the circle, and the length of each of the sides will decrease to a point that if the athlete moves with a velocity of constant magnitude. Now imagine yourself as an athlete, and if you are like you can say moving with a constant magnitude along the circular path, the only change in his velocity is going to be because of the change in direction. Okay, and the motion of the athlete moving along a circular path is an example of uniform accelerated motion. Okay, what can you conclude? That the motion of athlete who is moving along a circular path, that is an example of accelerated motion, right? So we know that the circumference of a circle of radius r is given by 2r and pi. Now if you remember that pi has a specific value, that is 3.14, it's just an extra information, it has not been given over here to you. So if the athlete takes t seconds to go one round along the circular path of radius r, then the speed, which we represent it as v, we can give it by v is equal to 2 pi r upon t. Okay, so this becomes equation 8.13. And when an object moves in a circular path, with uniform speed, its motion is called uniform circular motion. So here you get the definition of uniform circular motion as when an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Okay, so I just want you all to write the formula and even the definition for uniform circular motion. Okay. I hope every one of you are writing it. So sorry. I hope everyone has taken a note of it. Now we have an activity 8.9 and summary discussion that I'm not going to start with today because we are even left with exercise questions. So we'll have one more part for the whole lesson. But I hope like you have understood about the uniform circular motion, whatever we discussed today about that, right? So we'll discuss this activity and then the summary discussion for the lesson in the next part. Okay. After this, we have few exercise questions to discuss. So we'll be doing that in the next class. Okay, but make sure you're going through it and you're practicing the questions as well. Okay. I hope every one of you are going through the question. So this is how we will be ending up with the whole lesson motion, and I hope whatever we have discussed so far in the lesson, every one of you have understood it. Now next part, we will be discussing on the exercise question as well. So every one of you might be aware of like each and every question and what exactly you need to write as well for the answer part. Okay, so you have got one more chance to revise the lesson. Make sure you utilize that. Okay, so I'll just start with the exercise question and the summary in the next part. Thank you, everyone.